All right, let's dive into the world of commercial composites. You know, these are the unsung heroes behind so many of the things we use every single day. We're going to figure out how one family of materials can be used to create such a huge range of products. And the answer? Well, it's not just about the material itself, but how you put it all together. Let's get into it. So think about this for a second. On one hand, you've got a massive, one-of-a-kind yacht hull. And on the other, you've got over 1 million identical, kind of complex car bumpers. How on earth is that possible using the same basic ingredients? Well, the answer is pretty fascinating. It all comes down to what we call composites. Now, at its core, a composite is just a material made from two main things: a reinforcement, usually strong fibers like glass, and a matrix, which is typically a plastic resin that acts like the glue, holding everything together. Kind of like reinforced concrete, but for high-tech plastics. But here's the kicker. The real secret sauce that makes all this possible isn't just the material. It's the process. It's the recipe you choose for combining those fibers and that resin. That choice determines everything: the size, the shape, how many you can make, and how fast you can make them. So let's start at one end of the spectrum. We're talking about the low volume, almost handcrafted methods you'd use to create those huge custom items. These are the layup methods. First up is the most hands-on method of all, called wet layup. Just like it says, it's a totally manual process. And honestly, the best way to picture it is like industrial strength paper mache. You're literally taking sheets of dry fiber, putting them in a mold, and then painting on liquid plastic to create the final part. And you can see how it works right here. You start with a gel coat to get that beautiful, smooth finish you see on a boat. Then you lay down the fabric. After that comes the really hard work, pouring on the resin and using these little rollers to work it deep into the fibers, making sure you push out every single air bubble. And you just keep doing that, layer after layer, until it's as thick as it needs to be. So the bottom line is, this method is perfect for things like custom boat hulls or one-off prototypes. Why? Because the mold itself can be super cheap to make. You can build it out of wood or even plaster. The big trade-off, though, is that it's slow, it takes a lot of manual labor, and the final quality really, really depends on the skill of the person building it. Now let's look at a slightly faster version of this: spray up. So instead of carefully laying down sheets of fabric by hand, you use this special spray gun. This thing is a really clever piece of equipment. It takes long strands of glass fiber, chops them up inside the gun, and sprays them out, already mixed with resin, right onto the mold. The key trade-off here is pretty clear. It's speed versus strength. Spray up is way faster, and it's great for making complex, curvy shapes. Perfect for something like a swimming pool or a water slide. But because those fibers are chopped short and just sprayed on randomly, the final part isn't going to be quite as strong as one that was meticulously laid by hand. Okay, deep breath. We're about to do a complete 180 here. We're leaving the custom workshop behind and heading straight into the factory floor. We're talking high-volume, high-pressure processes designed to crank out millions of parts. First up is compression molding. For this, you start with what's called a charge, basically a pre-made blob of resin already mixed with fibers. You drop that into a heavy-duty heated steel mold, and then you use a massive press to squeeze it into its final shape while the heat cures it solid. Now, that charge material usually comes in two main flavors. First, you've got sheet molding compound, or SMC. And just like the name says, it comes in sheets and has longer fibers, which gives you stronger parts. Then you have bulk molding compound, or BMC, which is more like a dough or a putty with shorter fibers. It's not as strong, but it's great at flowing into really tiny, intricate details in a mold. So it's a classic choice between strength or complexity. But what if you need to go even bigger? What if a few 100,000 parts a year just isn't going to cut it? What if you need to make more than 1 million? For that, you need injection molding. This is the undisputed king of high-volume manufacturing. The best way to think of it is like a giant, super high-pressure hot glue gun. It takes these little plastic pellets, melts them down, and then injects that molten plastic into a mold with an incredible amount of force and speed. This table really sums it all up. But the most important thing to see here is the difference in materials and cycle time. See, injection molding uses thermoplastics. Those are plastics you can melt and refreeze over and over again, kind of like an ice cube. This is what allows for that insane cycle time of just a few seconds. Compression molding, on the other hand, usually uses thermosets. These plastics go through a one-way chemical change when they're heated, like baking a cake. You can't unbake a cake, right? And that chemical reaction takes minutes, not seconds. Okay, so not every part in the world is a giant boat hull or a tiny car bumper. Sometimes you run into unique challenges that need a really clever, specialized solution. Let's start with pultrusion, and the name here tells you everything you need to know. It pulls the material through the machine. So instead of pushing plastic into a mold, you're continuously pulling bundles of fiber through a tank of resin, and then straight into a heated die that shapes it and cures it solid. And here's what that looks like as this amazing, non-stop production line. Fibers get pulled off these big spools, they get saturated in resin, they're formed in the die, and they come out the other end as a finished, solid part that just gets cut to whatever length you need. It is the perfect way to make things that have a constant shape, like I-beams or rods or the frames for windows. And finally, we have reaction injection molding, or RIM. Just like the name says, this process is all about a super fast chemical reaction. You take two liquids that are extremely reactive, mix them together, and inject them at low pressure into a mold, where they turn solid in just a matter of seconds. It is incredibly fast. And this basic process has a whole family of variations you can use. You can add short fibers to the mix, and you get reinforced RIM, or RRIM, which makes the part stiffer. Or you can put a pre-made mat of woven fibers into the mold first, and then inject the resin. That's called structural RIM, or SRIM. And that's how you can make really large, strong parts like car body panels with unbelievable speed. So we've seen it all now, from hand-built giants to mass-produced millions, and these really clever, specialized solutions. Which brings us all the way back to our main point. Picking the right manufacturing process isn't just a technical choice, it's a huge strategic decision. This chart right here really brings it all home. It lays out the fundamental trade-offs you have to make. At one extreme, you've got layup, very low volume, but also very low tooling cost. That's your one-off boat hull. At the complete other end of the universe is injection molding. Crazy high volume, but also crazy high tooling cost. That's how you make 1 million car bumpers. And everything else we talked about falls somewhere in between, each one offering its own unique balance of cost, speed, and complexity. It's so clear that when you're working with composites, the process you choose is every bit as important as the material itself. And that leaves us with one last, really exciting question to think about. As our materials get even smarter and these manufacturing processes get even faster and more automated, what are the incredible things we're going to be able to build next?